So today I'm going to give you an update on white mold at SCN, and I'm really going to focus on two different pieces of white mold and SCN. And before I get into it, I just want to say that some of the work that Michael Bunch has done at Carrington is just fantastic. And he's been able to show by optimizing the fungicide application, you might increase the effect of that application by maybe 30% in yield. It's quite remarkable. And I'll explain a few things about that, but I'm going to focus on the timing. The second piece of this that I'm going to talk about is soybean cyst. And there's really two things I want to show you that I'll get to. One is the distribution. Where is this thing moving around in North Dakota? And if you're from Minnesota, just imagine a mirror image. It would be very similar. And then we do have some pretty good information now on some of the varieties and their resistance level to SCN. And so that'll be the last thing I show you. So those are really the two things I want to focus. So with white mold, this is where we're at right now in the season. Okay, so here's a bunch of seeds. I grabbed this from a field. The black structures are sclerotia. And that's what the white mold pathogen survives as. So these are in the field right now. In the spring, or when it's wet and the environment's favorable, they're going to germinate and they're going to produce these little mushrooms. So these mushrooms, they release the spores, and those black structures have to be close to the surface for the mushrooms to form. So within an inch or two of the soil profile with water, they'll start forming. So that's the first piece of this. So you need a little bit of water at the right time of the year to get these things germinating. Once you do, you have spore flushes. So this pathogen is pretty impressive. The weak spot is that the spores that generate don't attack healthy green tissue. They need some senescing or dying tissue to start the process. And so this is a sunflower leaf. The white mold pathogen also hits sunflower. And what had happened here, I'm walking through this field and you have a leaf, a sunflower leaf, horizontal where some of the florets are dropping on. Those spores that landed on the florets will start digesting it there and then spread to the healthy green tissue. And so you can see this almost concentric rings of that pathogen coming from the infected floret. For this to happen, you need it relatively cool. You can get white mold when it's 80 degrees, and you need it relatively wet. It doesn't have to be a swamp, but you don't get a ton in a desert. Every broadleaf crop is susceptible. Okay, so this is not relegated to just dry beans or soybeans. If you have canola or other things, it's the same pathogen, same system. All right, and I think you probably know it from there. It'll go into the stems, it'll cause lots of problems, it'll lodge the plants, and it'll produce more black structures, more sclerotia that you can see on the right. Okay, so fungicides are a big part of managing white mold. There's been a lot of updates, and I'm going to show you where you can get more. And it's more about optimizing the application. And again, Michael Bunch is fantastic at this. He's got information on fungicide efficacy, droplet size, water volume, and more things on the website I'll give you at the end of the presentation. So he's been working on multiple components, in addition to the things that Greg talked about earlier with different levels of disease and row spacing, planting population, and such. But I'm going to focus on timing. Timing, I think, is probably the most important thing right now. And it's partly because of the impact that you can have managing this disease with just subtle changes in when you apply. So the questions that he's been trying to answer related to timing are often related to canopy. Is the timing different if the canopy is open, or is it different if it's closed? The microclimate changes a little bit. Is the timing different with one application or two applications? Do you want to start at the same time, or do you want to go earlier? So he's been working on answering these questions. So I'm going to throw a big data slide at you. Don't be afraid. I'm going to break it down and we'll walk through it one at a time. And this is really good information. Okay, so this is the way he normally presents his work. And like I said, we're going to break this down. I think everyone will understand this when we're done. Okay, so this is what normally you'll see if you go to his website. If you go to the North Harvest Research Magazine and look at the reports, it'll look like this. So let's tear this apart a little bit. Okay, so the first thing I would say is that this particular trial, this particular data set we're looking at, is focusing on fungicide applications where the canopy is open. So he defines it as less than 95% canopy closure that's the canopy is open, okay? We're looking at Pintos here, but he also has work on other market classes. And he has single applications. So a single fungicide application, he'll have some information there. And then he'll have 2 applications, and he's got information there. Okay, so let's focus on the first application, or the single application. So what we're looking at here, as you look at this, he's got different treatments, and the treatments are timing, okay? So he's focused on these different treatments, where you have first on the right-hand side, you have a non-treated, okay? So this is a application that doesn't exist, right? This is just how much white mold you have when you don't spray. But then the next 4 things down are timing. And the way he measures, or the way he's looking at timing, is plants with initial pin-shaped pods. So this is percent. So a pin-shaped pod is that tiny little pod, really, really skinny, that starts to develop when the blossoms are dead. So you could think about this as kind of dead blossoms as well, but the pin-shaped pods are very small. So we'll go through this one at a time. So in the fungicide trial, a single application, canopy open, the non-treated control, where there's no fungicide application at all, had 47% of the canopy was hit with white mold. That's a lot. That's a lot. Where he put a fungicide application down, where right before there was any pin pods, so really preventative, right? There was maybe a little bit of a reduction. When he waited a little longer, so 10 to 40% of the plants had at least a pin pod, disease was reduced a little more. Where he waited until the majority of the plants had at least one pin pod, you can start to see statistical reductions in disease pressure. By the time he waited till almost every plant had a pin pod, you could see that same statistical reduction. And I should have prefaced this by saying in his trial, what he's doing is he's got 15 gallons per acre, and this single application is topsin at either 30 or 40 ounces. Okay, so what did this do to yield? So in the non-treated, it was 2,300 pounds. Okay, not too bad, right? That's pretty good. He waited until there was, put it on kind of preventatively, about 2,500 pounds. He waited a little bit longer, but still an open canopy, just a few more plants have pin pods. The yield doesn't really change much. But as he waits further and further, so the majority of the plants now have pin pods, he's starting to see a statistical increase in yield. So that's about 300 pounds and almost 400 pounds by the time almost every one of them have a pin pod. So the old kind of rule of thumb was get in there as soon as you see blooms, early to mid bloom spray. But he's showing that actually with an open canopy, you're much better off waiting. The next little piece of information that he's sharing is what are the yield gains over the non-treated? So the non-treated, the yield gain is 0. You get a little bit of boost in yield here, applying early, but you can see if you wait, you're in the 300 to 400 pound range increase just by waiting. Okay, so the message here with the canopy open, and in his case, these trials, I think there was 5 trials, the temps were kind of in the low 80s, so not super conducive, but he's putting spores down and he's creating a favorable environment. The message is that you really have the best bang for your buck if you delay that application until 70 to 85% of the plants have pin pods. And this is different than we would talk about maybe 5, 6, 7 years ago. So, and he's got rock solid data here. Okay, so what about 2 applications? A lot of growers will spray 2 applications. Okay, so let's go through this again. So you have, I'm going to present both these together. So you got these 2 applications, and the way this is set up, first application is still that topsin at 30 or 40, and then Endura at 10 to 14 days later. So if you don't have any application, the non-treated here is 47% of the canopy. Every single application after that is reducing disease severity statistically, okay? And there's benefit if you wait a little bit. So this is Michael's yield gain information again, and we're going to talk about this. So here, he separated it out into 2 columns. The first is 3 studies. So there's 3 studies here. The second is 2 studies. So in 3 of the studies, the yield gain from the non-treated was 500 to 600 pounds applying early, but waiting until you have 50% or more of the plants having pin pods increased that yield to almost 900 pounds. So there's a benefit to waiting even in this scenario. In 2 of the studies, there was no benefit to waiting. Okay, and this is probably due to environment difference in the studies. Okay, so the message here is that if the canopy is open and you're going to look at 2 applications, you probably still want to delay your first application until 15 to 80% of the plants have pin pods. And that is a little bit counterintuitive initially, but if you think about when the canopy is open, when it's closed, when it starts closing is when the conditions become highly favorable because of the long dew periods and things. Okay, so let's flip this a little bit. What happens when more than 95% of the canopy is closed? Okay, so this is canopy closure. Okay, so you're in your field, canopy is closed. How does that change what you do? It's set up the same way. We have a non-treated, we have less than 10% pin pods, 10 to 20, 60 to 80, and 100%. Scale's a little different, but concept's the same. So let's look at the single fungicide application first. And you can see there's 87% of the plants had disease. And if you hit it really early, it's basically the same. The next 3 didn't make a whole lot of difference. Numerically, a little less disease severity. And I'm sorry, it made a difference statistically and numerically, but it wasn't much different between 10% and 100%. This implies that you want to hit it earlier than if the canopy is open. And let's look at the yield. And this fleshed that out as well. So the non-treated and that preventative early application were the same. They were both more or less 1,200 pounds an acre. Okay? But as soon as those plants started to throw pin pods out, you had about a 500-pound gain. And it wasn't a lot different if you waited till 100% of the plants. But you got your best bang for your buck really starting at 10% pin pods. So it's earlier. And you're not penalized for waiting a bit. Okay, and you can see in the yield gain, these are essentially all the same. If you look at 2 applications, and again, this is starting with Topsin, ending with Endura, 10 to 12 days apart. The non-treated control had 87% of the canopy was full of disease. The yield was 1254. This earliest preventative application did reduce disease and it increased yield. And that's because you have 2 applications, right? But the best bang for your buck, again, was starting at that 10%, 10 to 20% pin pods. And this is a yield increase in this trial, these trials, I should say, there's 3 studies combined, is almost 1,000 pounds. You still have a significant yield increase over the non-treated, waiting a little longer, but that yield does start to drop and the disease starts to increase. Okay. So what does this mean? So if you have a single application, even when the canopy is closed, you can delay that until 60 to 80% of the plants have pin pods in this environment that he's working with. However, if you're putting down 2 applications, get that first one on when 10 to 20% of the plants have pin pods. So you're going earlier. Okay, a few other things about white mold before we shift gears. As the canopy closes, you want to increase droplet size. Okay, and that's simply because when you have an open canopy, you can get that mist in there quite easy. But once the canopy closes, it's hard to get to the point where you need to get those flower petals, the inside of the plants. So you will want to increase droplet size. Water volume, he's been testing that for a few years, and it makes me a little uneasy, but he's found almost no difference between 10 and 25 gallons per acre in his trials. And I encourage you to take a look at that. He's done quite robust work on this. And then the last thing is that there's multiple effective fungicides, and you can find that on his site as well. Okay, switching gears to soybean cyst nematode. So this is a parasitic worm, and it hits soybeans and dry beans. This is a Minnesota field. That photo was taken by Guiping Yan a few years ago. This is kidneys, and it's getting taken down fairly hard by this parasitic worm. A few things about it. I mentioned it's soybean and dry bean only. There are a few wheat hosts, but soybean and dry bean are the crops we worry about. And it's invasive and actively expanding. It moves with soil, so it's not really swimming around. It's moving by anything that moves soil. So that could be farm equipment, humans, boots, birds, water, flooding, whatever that is. And actually right now in a lot of our area, we don't have much snow cover. If you're seeing soil blow around? Well, SCN will be part of that if there's a hot SCN area. It's favored by high pH, warm weather, and dry conditions. And we have had all of those for the last couple of years, at least in some areas. And you typically in soybeans don't see above ground symptoms until it's too bad. And we think the same thing is probably true with dry beans. To reiterate that it's an expanding problem and an invasive pathogen, it was introduced into the US in the 1950s. And you can see the leading edge of these red counties, which indicate that a county has or a field has SCN. We now have it in several areas in Canada as well. Okay, now just because you have it in the county doesn't mean every field's infected, of course. There's a difference in density of this. So the North Dakota Soybean Council has been very good about giving us the ability to help growers sample. And so this is a grower-based sampling program. And the way this works is that you pick up these sampling bags from the county extension offices in the state, or myself or the North Dakota Soybean Council, get out in your field, send this back into the lab that we're using. In this case, it's AgVise, and the North Dakota Soybean Council covers all the lab fees. So in a way, it's free. It's your checkoff dollars at work, quite literally. So there's been about 5,500 samples taken in the state since it started in 2013. And just as a quick explanation here, we're measuring nematode levels, and eggs are what we care about. Think of it as like risk factor 2. Anything that's black showed up as a negative. And throughout the years, about 70% of the samples are negative. Anything that's gray is a very low level positive. So I would call that inconclusive because there's other nematode eggs in the soil. SCN's not the only game in town, but some of these will be real. When you look at the colors, all of that is real, okay? And as you go from green to blue to yellow to red, the numbers get very, very high very fast, okay? So the first thing I'd like to get your eyes on is areas where you're at growing dry beans where there's not a lot of samples, right? So for example, Walsh County, right? Walsh is upper right corner here, one down from Pembina. There's a lot of dry beans in Walsh, but there's only been 10, 15 samples outside of the valley. And we already know that Grand Forks has got it quite a bit. And then there's a couple really hot spots in the southeast part of the county. So I would encourage everyone, if you're growing dry beans, to consider sampling for SCN. Okay, but let's take away these negatives so you can see, and the inconclusives. So you see just where we've for sure got confirmations, and there are others, in those low-level positives. I would suggest that if you're from Minnesota, you have a mirror image on your side. And if it's closer you get to the St. Cloud or Sauk Center, the increase of SCN is even higher probably than in North Dakota. If you're from Canada, we know there's confirmations in Manitoba. I would expect the density to be very, very limited in that, but that will change. Okay, so with SCN, what do you do about this? So you've got a couple things to keep in mind. The first thing that I would recommend is you should sample. And the way you would sample for SCN is the same in soybeans or dry beans. Wait till about harvest time. So the pathogen the nematode, I should say, has to reproduce. And it'll go 2 or 3 life cycles in a season. So if you're looking to find it the first time, wait till the end of the season. Let it get to its highest level it's going to get, and then you might detect it. And you want to focus on areas where you would introduce soil. So field entrances are an obvious spot, but shelter belts in a winter like this, when soil is blowing all over the place, shelter belts will help collect soil. And you can sample shelter belts for soil. Dave Franzen did this years ago at shelter belts and ditches and found SCN all over it. Sampling is different than a fertility sample. It's a biological organism that lives on the roots. So 6 to 8 inches deep, and aim for the roots. You're trying to collect this organism. And then, of course, send it into a lab and see what you've got. Managing this, crop rotation is really important. And a little asterisk here, if you're growing soybeans as well, you really, really want to check for SCN because you have more management tools right now with soybeans. So if you can manage it in soybeans, if you've got it, that also helps your dry beans. But crop rotation is very important. Remember, there's only 2 crops we worry about, soybeans and dry beans. Genetic resistance isn't necessarily a thing in dry beans yet, but we're working on resistance. But there's a different level of resistance / tolerance in dry bean varieties. And that's what I'm going to pop up here real quick. And then seed treatments may be an option in the future. There's certainly a lot on soybeans, and we'd like to get more testing on dry edibles. Okay, so the resistance thing. So this is work that's been done by Dr. Guiping Yan. She's our nematologist, and she's excellent. And she's taken a lot of different varieties from different market classes and evaluated them for something called female index. So simply, this just basically means how well do those female nematodes like to eat that variety or plant, okay? So if the females really get on and stick on and reproduce really quickly, that has a high female index. And if they don't like it, well, it's low, okay? 100 is the top of the scale, and that's a pure susceptible soybean, okay? So as you're looking at this, 100 would be pure susceptible soybean. Okay, so let's switch this a little bit. Let's pretend that we're talking about resistance level in terms of resistant, moderately susceptible, and susceptible, okay? And we'll throw lines across. And what I want you to take a look at is that susceptible category. Yeah, there are some dry edibles that are susceptible. There's nothing that's at that top 100% line. There's nothing here that's as susceptible as a susceptible soybean, which is good. Quite a few of the varieties would be considered moderately susceptible, with a couple moderately resistant. I think in general, this is really pretty good news because we didn't have a really good handle on it until some of this more recent data. So our dry beans, and there's some fluctuation between variety and market class, our dry beans are generally considered somewhere kind of the high moderately resistant to mid moderately susceptible, with a few that are a little bit more susceptible than that. Okay, but that's the last thing I have for you. If you want to access this, which what I would encourage you to do, North Harvest has a very good research report that's published annually. The first QR code will take you there. You'll be able to find a lot of different things, including the things I talked about, at least to some degree. But that very same table on SCN resistance is there. And then Michael Wunsch has a pathology page. He's focusing on a lot of these optimization things, and you can see right up front where I copied the first research updates are dry bean fungicide timing, dry bean white mold droplet size, dry bean white mold spray volume, and there's a lot more than that. So I'd encourage you to visit those.